Hello, my dear learners. How are you all? I hope you all are good. Okay? I hope you all are doing good. So, here I am your computer educator. So, I am Yashvi. So, now we will start your book with chapter number first. Okay? So, in this video, we will covering chapter number first of your book. Okay? So, are you ready for the first chapter? Okay. So number first chapter is number system. You are thinking, ma'am, number system is basically based according to the subject maths. Yes, but no. This is different types of number system that we can use, that we can read, that we can learn in a computer class. So in computer also number systems are there. Yes, in mathematics, numbers are there. Okay, numbers are there. With the help of numbers, we can do addition, subtractions, multiplication, additions. Of course, like in the mathematics, in the computer also, if I'm talking about computer subject, it also has a number system. Like what is binary number system, how the decimal number system set is there, how we add number, how we subtract, how we multiply it, how we divide it. Okay. So these things related to computer, what are these things? Okay, so are you excited for chapter number first of your book? Okay, so let's start chapter number first. Chapter number first, number system is a chapter name. So first you have to meet your friend. So hi, I am Marvin. Okay, say hi to your friend. Okay. So we all know that a language is a medium using which we communicate with each other. Yes, we can say language is very, very important to communicate with you. Okay. In the same way, we can communicate with a computer and give it instruction using computer language. Okay. So see how we can able to communicate with computer. Of course, there should be a language between them. Okay, so that's why our language can understood by the computer and computer language is understood by us. Okay, so language is very, very important for the communication purpose. Now I am speaking also, so we are using our English language to communicate with you because you understand English language. I know English language, so we can able to communicate with it. Okay, so a computer understands only one that is language zeros and ones. This is called machine language or binary language. So we can call this language as a machine language or a binary language. So whenever we type some letters or words, the computer translate the 0 and 1 because computer can understand only numbers. See, this is very important. Like computer can understand only about the numbers. Okay, so a computer can understand the positional number system where there are only a few symbols called digits, and these symbols represent different values depending on the positions they occupy in the number. See, don't worry. I am hoping that this chapter is totally new for you. Okay, so don't worry. We can cover all the topics very slowly, very very interesting in a very interesting way. So that's why we can able to understand all the things clearly. Okay, so let's start. What is a number system? If I'm talking about what is a number system, so let's see. So number system is a set of values that is used to display different quantities. What's that? It is a set of value that displays different quantities. In other words, it is a system used to express number. What's that? It is a system to use to express numbers. It is a mathematical expressions that is used to represent numbers of a given set using digit or other symbols in a constant manner. In day-to-day life, we use the decimal number system. Normally in day-to-day life, we can use the decimal number system. So number system is clear. It is a set of value that is used to display different quantities. Okay, so it is a we can say normally if in day-to-day life we can use decimal number system which has been based on base of 10 as 10 digit like 0 to 9. Okay, so decimal number system is the most common number system. So this number system is the most common one. Other popular number systems include binary number system, octal number system, and hexadecimal number system. So these number system is also there. We will see one by one what are they. Okay. First, before starting that, we have to learn the types of number system. We are done with number system. Now we will see what are the types of it. Let's see. Broadly, there are two types of number system, positional and non-positional. What's that? Positional and non-positional. Let us read about them. Let's read about positional number system and non-positional. First, we will start with positional number system. Okay, so the features of positional number systems are as follow. So you have to follow these features. Okay, so what are these features? Let's see. Use only a few symbols called digit. What? We can use few symbols called digit. These symbols represent different values that depend upon positions that occupied in number system. What's that? So of course, in the because we already know in the position means you can, with that we can able to identify the position. Of course, we can able to identify position with the help of digit only. So use only a few symbols called digits. These symbols represent different value. These symbols means these digits represent different values that depend upon the position they occupied in the number. Of course, in the number system, these symbols first of all describe their position of that number. Okay, so the value of each digit is determined by the digit itself. Of course, one has one values. Okay, with the help of we can say digit, we can able to identify the value. Okay, of course, 5. We know 5 comes, we can say before 6 and after 4. We all know. So every number system, every digit has a fixed value. So the value of each digit is determined by the digit itself and the position of the digit in the number. Next is the base of the number system can be calculated as base. So a number system also has a base. Base means total number of digit in the number system. That is denoted by the base. Okay, like in decimal, the base is 10. In binary, the base is 2. So we can say the total number of digit that is there in that number system. Number systems are different types. We already know binary number system is there. Octal number system is there. Hexadecimal number system is there, and decimal number system is also there. So base value describe the total number of digit in a number system. So total number of digit is described with the base. Okay, with the help of base. So every number has a base on it. With the base, we can identify the total numbers of digit that is there in the number system. Okay, so the maximum value of a single digit is equal to the one digit less than the base digit. Of course, the base digit is 10. So the value of that number is 9 less than. Okay, so we can say the maximum value of single digit always one digit less than the base number. Okay, so we will see what is base number and how these number system have different base numbers. Okay, so positional number system is clear to you. With the help of that, we can able to identify the position of that number. Second is non-positional number system. So what is non-positional number system? So use symbols such as 1, 2, 3. See, these are the symbols they can use. Here we can see these symbols denote 1, 2, 3. So we can use this one. Okay. Next, each symbol represents the same value in respect of its position and the number. Third, the symbol are simply added to find out the value of a particular number. Okay, so this is non-positional number system. I'm hoping so positional and non-positional are totally clear to you. Okay, so in non-positional we use symbols. Symbols represent the number. Okay, such as this. Now we'll see need of a number system. Why we have this need of this number system? Does they play any important role? Let's see. So the number system is the method by which we can represent number in the computer architecture. So what we can call, with the help of number system, we can represent number in a computer system because computer understand the number. Okay. So every value that we save or get into or from computer memory has a defined number system. The computer architecture support following number system. So they support these four types of number systems. So computer understand these four types of number system only. First is binary number system, second is decimal number system, third is octal number system, and fourth is hexadecimal number system. So these are the four types of number systems. Starting with the first one, base of a number system. How we identify the base of a number system? Okay, for example, if I write a number 10 and in the base I write 2. So with the help of 2 we can able to identify the type of number system. Yes. How? We will see. If I write 2 or if I write 5 and in the base I write 10. So with that base number we can able to identify the which type of number system I am talking about. How? Let's see. Okay, so don't worry for that. I will tell you. So we can say base of a number system. In the mathematics, a base is the number of different digit or combination of digits and letters that is used to represent number in a system of counting. See, these are the base we can use. First is 10. 10 base is the decimal base. Okay. So the base of a decimal number system is 10. So if the number system is decimal, so the base of that number system should be the 10. Base is clear to you? Okay. So it includes 10 digit. That, of course, 10 means it includes how many digit? 10 digit. 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is, we can say total number of digits are there in 10. Of course, 0 to 9. It represents any number using 10 digit. We can use 0 to 9 in that decimal number, and the decimal number have the base is 10. Second is base 2. If the base is 2, then the number system is binary. What's that? The number system is binary. So the base of binary number system is 2. So if the number system is binary 1, so the base of that is 2. As it contains only 2 digits like 0 and 1. Because the base is 2, so we have only 2 numbers in this binary number system, that is 0 and 1. These are the 2 numbers that we can use in the binary number system. And the base of binary number system is 2. Third is base 8. If the base 8 is there, that is octal. What's that? It is octal. So the base of octal number system is 8. Of course, if the number system has a base 8, that means it is octal. Octal described means 8 something is 8. Octagonal, hexagonal means 7. Okay, pentagonal means 5. Okay, so it's octal means this is 8. Then the base of that is 8. As it contains only 8 digits. Of course, it contains how many digits? 8. So base denote the number of digits that is there. So in octagonal, there are 8 digits, that is 0 to 7. If we count 0 to 7, how many digits are there? 8. Now the fourth one is the base 16. That is hexadecimal. So base 16 we can call hexadecimal. So the base of hexadecimal number system is 16. So the base of that is 16. That means how many digits are there in that? Very good, 16. Okay. So 16 digit, like in the number, if I'm talking about 0 to 9, and in alphabet A to F. Now it is okay. Now it is okay. See, this is 10 and this is 6. So it is total 16. So if the base is 16, that means it is a hexadecimal number system. So 4 types of number systems are clear to you? Okay, let's move on. First type of number system, that is binary number system. We will see one by one what are they. Okay. Computer is an electronic machines and knows about only 2 modes: on represent by 1. What's that? On represent by 1 in the computer, and off represent by 0. On represent by 1 and off represent by 0. The number system having just these 2 digits, 0 and 1, is called binary number system. So in the binary number system, we have only 2 digits, that is 0 and 1. That's it. Okay. So that much is clear. And the base of that number system is 2 because it contains only 2 numbers. Now we will see some features of it. Some features. Okay. So let's see. It is a positional number system. What's that? We in the starting we see some of the numbers are positional one and some are non-positional one. So binary number system is positional one. So it is a positional number system. It has only two digits, that is 0 and 1, and the base is 2. This much is very important. I highlight it for you, so that's why. So I highlight it for you. This is how we can highlight this one. Okay, 0 and 1 and the base is 2. Third is the maximum value of a single digit is 1. What's that? Of course, 0 to 1, that means in that digit is less than 1. Okay, not greater than 1. So because the maximum value is 1, so the digits are less than 1 only. So the maximum value of the single digit is 1 less than the base digit. And the fourth one is that each position of the digit represent a specific power of the base 2. See, this is how 1 0 0 0 0 1 and the power is 2. Can you see here? Here, I will highlight it for you. This one. Can you see this number? This number has a base 2. That means they represent a binary number system. So in a binary number system, the rightmost digit called least significant. What's that? Rightmost digit is known as least significant, that is LSB. And the leftmost digit is known as MSB, that is most significant byte. Okay, so this one side should be LSB and the other side should be MSB. So these two digits are there. Okay, now I am hoping so the binary number system is totally clear to you. Yes? Okay, now we will see decimal number system. So what is a decimal number system? Okay, so the decimal number system has only 10 digits from 0 to 9. Of course, they have only 10 digits. Okay, start from 0 to 9. Okay, so the base value of decimal number system is very good, 10. Okay, so every number is represented using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because the numbers start from 0 and end from 9 in the decimal number system. So the base of the decimal number system is 10. So in the decimal number system, the base value is 10. Because it has 10 digits, it is as simple as that, because it contained only 10 digits. So the base value is 10. Now we will see features of decimal number system. So what are the features of it? Okay, so let's see one by one what are the features of the decimal number system. Starting with the first one, it is a positional number system. See, this is also a positional number system because we are using digits in it. Okay, we are using numbers in it. So that's why it is also known as positional number system. Second is, it has 10 digits. How many digits? 10 digits, starting from 0 to 9. And the base value is 10. What's the base value of this decimal number is 10. Okay. The maximum value of the digit number is 9. Of course, in that 0 is the minimum value and 9 is the maximum value in it. Okay. We use this number system to perform day-to-day calculations. Of course, see, can you see the base value of that number is 10. So 10 represent this is a decimal number system. Okay. Now we will see octal number system. What is octal? So I'm hoping so decimal and binary is clear to you. Now we will move on to the third type, that is octal number system. Okay, so let's see octal number system is what? So the octal number system has only 8 digits from 0 to 7. So it contains only 8 digits, starting with the, we can say smallest number should be the 0 and the largest number is 7. So every number value is represented by 0, 1, 2, 3, 4, 5, 6, 7 in this number system. The base of octal number system is 8. The base of that number is 8 only because it contains only how many digits? 8 digits. Okay. So the value of that is 8. Okay. Now we will see some features of it. So some features of octal number system are, starting with the first one, that is, it is a positional number system. Of course, this is also positional because we are using numbers, we are using digits in it. So it is a positional number system. Second is, it has 8 digits. Of course, it has how many digits? 0, 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, only 7. Okay, so the base value is 8. So the maximum value of the digit is 7, which is 1 less than the base value. Of course, in the previous in the starting of the chapter, we read about the maximum value of the number is less than the base value. So it is 7 because the base value is 8. Okay. Fourth is, since there are only 8 digits, so it's 2 power 3, that is 8. Of course, if we can solve 2 power 3 is 8. Are sufficient to represent any octal number system in the binary. For example, see the base value of that number is 8. So that's why we can able to identify this is the octal number system. Next, we will see the fourth one, that is the number system is known as hexadecimal number system. So I will highlight it for you. So we will highlight that is hexadecimal number system. Okay, so let's see what are they. Because decimal is there, so in the decimal we have how much value? From 0 to 9. Of course, the base value is 10. So they contain numbers and they contain alphabets also. Okay, hexa represent how many? 6. So 6 alphabets are there and decimal represent 10. So we have 10 numbers in it, like start from 0 and end from 9. So it contains numbers and it contains alphabets. That is hexa for 6 and decimal for 10. So it's hexadecimal number system. Okay. So it is a combination of hexa and decimal. So a hexadecimal number system has 16 alphanumeric value because it has alphabets and numerics in it. Okay. So 0 to 9 is the numeric value and A to F is the alpha value. Every number value represent with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E, F in this number system. So the base of the hexadecimal number system is 16. So the base of that number system is 16 because it has 16 alphanumeric value. Here A is 10. We can call A is 10 and B is 11. C is 12, D is 13, E is 14 and F is 15. Okay, see, features of hexadecimal number systems are, what are their features? Starting with the first one, it is a positional number system. Of course, it is a positional number system. Second is, it has 16 symbols of digits 0 to, these are the numbers that we can use, numbers and the alphabets. And the base value is 16, of course. So the base value 10, 0, 10, 2, 8 and 16. These are the 4 base values. Okay. So the maximum value is, the maximum value of a single digit is 15, of course, less than the base value. So base value is 16. So the number should be 15. Okay. So the symbols of A, B, C, D is 10, 11, 12, 13, 14, 15. Okay. So since there are only 16 digits, so 4th byte means 2 power 4, that is 16, are sufficient to represent any hexadecimal number system. Okay. Start with, we have each position in hexadecimal number system represent as 0 power of the base 16. Example 160. The last position of a hexadecimal number system is x power of the base 16. So we will write 0 of it. Okay. We will see how we can convert all these things. Okay. So don't worry how we can do. First, we will see converting decimal number system to binary. Decimal is the base value is 10 and we can convert into binary. Binary means 2 numbers are there. So how we can able to convert these numbers? Let's see. So to convert a decimal number to binary number, we have to divide the decimal number by 2. What we have to divide that number? We have to divide the number with 2. So to convert decimal number system to binary number system, we have to divide the decimal number system by 2 repeatedly and write the remainder on the right hand side. See, the decimal number which is given to you, we have to divide that decimal number by 2 and we have to write the remainder of it on the right side of that number. So this process should be continued till we reached a 0 quotient. Till we do not find a zero quotient, till then this process will be continued. When the remainder will be 0, then this steps are over. Okay, so we will see the remainder have to read from bottom to up. Of course, remainder you have to read from bottom to up. Okay, so the remainder have to read from bottom to top to form the binary number. Let us consider a few examples. So let's see with the example. Starting with the first one, example 1. Converting decimal number 130 into binary equivalent. So you have to convert 130 to binary number, because in the binary number system, the decimal number system has to divide with 2, and we can write the remainder on the right side of it. Starting with, like here the number is, so here we can see, for example, one example is given for you. Okay, so the example is that, okay, so I'm hoping this much is you have to write here. Please check this one. This is 25. So you want to convert 25 into the binary number. Okay, it's not 130. Okay, so you have to convert 25. Okay, so see, now 25 is here, and of course you have to divide the number with 2. Okay, so you can write 2 here. Okay, if you divide 25 with 2, so we can see here we can able to divide. I am hoping so it is clear to you how we can able to do. See, you can write 25 here. Okay, and if you want to divide it with this, so of course 2 ones are 2. Okay, and the 5 is there. Okay, if you see, so it's 2 2s are 4, and the remainder should be 1. So here we can see the remainder is 1, and we can see the quotient is 12. Okay, so see how we can, in here we can write the quotient on the middle side, and here on the right hand side we can write the remainder. Then 12 also divided by 2. What's that? 12 also divided by 2. So this process continue till the quotients become 0, not the remainder. Quotients become 0. Then, okay, see, now we can divide 2 to 12. This is 2 6 the 12. Then the remainder is 0. Then 6 also again divide with 2. We know 2 3s are 6, and the remainder should be 0. And the 3 divided by 2, if you divide, we can know it is, quotient should be 1, and the remainder is also 1. Yes or no? If I divide 3 with 2, so it is 2 1s are 2. So remainder is also 1, and quotient is also 1. Now 1 is divided by 2. Can we able to divide? No. So the quotient should be 0. Okay, and the remainder is 1 here. Okay, so now this process is completed because we get 0. Okay, so we can say, and we can write this number, this remainder as an answer: 1 1 0 0 1. So 25 base 10 is converted into binary number, and it is formed 11001 base 2. Okay, now second examples are there. See, you can solve these things in your home also. Okay, find the binary number of 40, find the binary number of 45, like this. Okay, see, converting binary number 3 to 1 has a see, converting decimal number 3 to 1 has a binary number. Okay, so 3 to 1, first you have to divide with 2. See how we can able to divide. I am hoping so it is easy for you. I know you all know how to divide everything, but if someone is new, so for them also I am writing it one by one. Okay, so you have to divide with 2. Of course, if you want to divide 2 with 3, so it's 2 1s are 2, and the remainder is 1. Of course, now the 2 comes here, then 2 6 are 12. Now we can get the 0. Okay, so we can write, we don't write the 1, we can write the 0. Okay, see, the remainder is 1 here. Can you see? The remainder is 1 here. In this we can see this one, how we can write quotient 0. Okay, so we can write now 160 is divided by 2, and we can see 160 divided by 2, it's 60. We can say 80 comes, and the remainder is 0. Now 80 also divide with 2. Of course, 40 comes. See, if you want to divide 80 with 2, so 2 4s are 8. and the 0 comes above. Okay, so we can write this is a 40 and the remainder is 0. So here we can write remainder is 0. Now 40 also divided by 2. See, 40 is divided by 2, then 20 come and the remainder is 0. 20 divided by 2, the remainder is 0. 10 divided by 2 is 5 and the remainder is 0. And 5 divided by 2, if we divide 2 with 5, if we say 2 divided by 5, so we can write 2 2s are 4. In that we can say the remainder is 1. So in here we can say the remainder is 1. Now we can say 2 divided by 2. So, okay. So we can say the remainder is 0. Okay. Here, if I divide, see the quotient becomes 0. So we can write this is the answer of it. Okay. So we can write with the bottom to up we can write. We can write 1 0 1 0 0 0 0 1 and the base value is 2 because we have to change it in the binary number. Okay. Now we will see converting binary number to the equivalent decimal form. Now we will see how we can, decimal to binary is clear to you. Now we will see binary to decimal. See how we can convert. So to convert a binary number to its decimal form, a positional value is given to every digit in the binary number. So the position value is in the term of power 2. Of course, we can say it has the power 2 because it is binary number. Okay, so the digit are multiplied with the positional value and the product are added to the decimal form. This is, let's see how I can do. Let's see, just concentrate. Now you have to convert 1001 into the decimal equivalent. See, first you can write 1 0 0 0 1 0 1 1 1 and the positional value is, of course, it is a binary, so we can write 2 power 0, 2 power 2 power 1. Here you can write 2 power 1, 2 power 2, 2 power 3, 2 power 4. Okay, then we can solve it. See, 2 power 0 is 1 plus 2 power 1. 2 power 1 is, yes, 2 power 1 is, so we can write this one. 2 power 0 is when we have to multiply this number with this number. Okay, so here comes up, what here comes up? It comes up 0. Okay, now if I talk about 2 power 1 with multiply 1, so it comes up 1. Now 2 power 2 is 4. When 4 multiply with 1, it comes up 4. Next, when 2 power 3 is 8 and 8 multiply 0, so it comes 0. Now we can say 2 power 4 is 16 and 16 multiplied by 1, that comes 16. So here comes up all these things. If we add all these things, it comes up 21 and the base value is 10 because we have to convert in a decimal form. So in the decimal form, it has a base value 10. Okay, so this is how we can convert binary number to the decimal form. Okay, now we will see another example like this example. Okay, this example we can able to convert into a binary number. Okay, so this number is also, you have to do like this process, you can follow this one. Okay, make a chart like this. Okay, this number should be written in the binary digit and then the positional value you can write 2 power 0, 2 power 1, 2 power 2, 2 power 3 and 2 power 4. Then after that you have to multiply positional value with binary digit and you can get this number 117 power, or we can say 117 base value is 10 because 10 base value is there because it is a decimal number system. Okay, now we will see computer arithmetic. So what is computer arithmetic? Okay, so let's see. As we know that a computer understands only the language zeros and one, so the data that is entered by the user is converted into binary code for processing. The processing may involve different kinds of arithmetic operation like subtraction, additions, multiplication and divisions on binary number. So we can say we can follow some arithmetic operations. So arithmetic operation include addition, subtraction, multiplication and division. Okay, first we will see binary additions. First we will see how we can able to add something. Okay, So this technique to add binary number is very simple and easy. The way we perform additions with decimal number, in the same way we perform addition with binary number. So normal addition what we are doing, that addition we will follow with binary number also. So how we can able to add? Let's see. Like this thing, A and B. Here we can write the numbers. Okay, 0, 0. Now if you add 0, 0, it comes 0. Now if you add 0 and 1, it comes up 1. Now if you add 1 and 0, it comes up 1. And 1, 1, if you can add, it comes up 0. See, this is very important. In the normal addition, we can write 2 because it is a binary number. So the number should not be greater than 2. It should be less than 1. That's why 1 and 1, if we can add 1 and 1, it comes 0. Carry over the 1, that is 10. See, this is how we can able to do. Okay, now this example is there. If you want to add this thing, so first you have to write this thing. 1000, and we can write 1, 1, 1, and on the left hand side we can write 0. Here we have to write 0 and 1. If you add 0 and 1, which comes, the result comes up 1. And if you add 0 and 1, it comes also 1. 0 and 1, 1. 0 and 1, 1. So 1, 1, 1 is the answer comes up. Okay, now we will see how we can able to subtract something. So see, it is also important. Here we have to A minus B. Okay, and you can get our answer C. So 0, 0, if I subtract 0 and 0, it comes 0. 1 minus 0, it's 1. It comes up 1. 1 minus 1 comes up 0, and 1 minus 0 is 1. That is important. Okay, see, this is the thing. Now you have to subtract this from this. So you can write this number is on the top of it, and bottom of it you can write this number. Now we subtract. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 0 is 1, and 1, 1, if 1 minus 1 is 0. Okay, now see the multiplication of it. Let's see how we can able to multiply it. Okay, see, these A and B numbers is there, in which you have to multiply A and B. Like 0 multiply 0, it comes 0. 0 multiply 1, it comes 0. Okay, if I multiply 1 multiply 0, it comes 0. And if I multiply 1 multiply 1, it comes up 1. It is similar as we can follow in the mathematics also. Okay, now one example is for you. Now you have to multiply 101 with 11. Okay, see, write 101 with 11. So this is how we can able to multiply 101 multiply 11. Okay, so now we know 1 multiply 1, the answer comes up 1. Okay, so we write 1. 1 multiply 0, 1 multiply 0, that means it is 0. 1 multiply 1, that's come 1. So it is the same one that we can use in the maths also. Okay, it is not the different one. Okay, so the answer comes up 1, 1, 1, 1, 1. Okay, this is how we can able to write the answer. Okay, so multiplication is over. Okay, now the last comes up the division. So how we can able to divide a binary number. Okay, so addition, subtraction, multiplications are totally clear to you. I am hoping so. Okay, so now we will see the last topic of it, that is division. How we can able to divide. So the method to perform division of two binary number is the same as of the decimal number. So let us understand how we can able to divide. See, this is the same we can able to, normally we can divide it. 101 divide with 1011101. So this is how, first we have to divide with 1. So 101 divide, the 1 is there. So the remainder is 101. Here comes a 101. And after that we have to add 2 zeros because we are taking two numbers simultaneously. So the answers comes up 0. Okay, so this is how the normal divide that we can use in the mathematics is the same way in the computer language we can able to divide. Okay, so yeah, this is the whole chapter. So I'm hoping so that this chapter, the number system, is totally clear to you. Yes, so that's all, my dear learners. Revise these things as well as also. Okay, because it is easier for you to understand if you revise this chapter well. Okay, so that's all, my dear learners. Thank you so much for watching this video. Have a good day. Bye bye.